We're going to go ahead and wrap up section 5.3. Let's look at this next equation. An equation whose degree is 2, we're expecting more than likely 2 answers. An equation whose degree is 2 is called quadratic. So we're solving this quadratic equation. I am going to take the 51x and move it over to the right by subtraction. So we're subtracting it from both sides. 0 equals 34x squared minus 51x. Once we have the 0 established, we factor. The greatest common factor is a 17x, leaving me with a 2x minus 3. If two factors are multiplied together to give me 0, either the first factor is 0 or the second factor is 0. In the first case, when I divide by 17, I get the answer 0. In the second case, when I add 3 and divide by 2, I get the answer 3/2. This next equation is not a quadratic, it's actually degree 4, which is sometimes called a quartic. Okay, the degree 4 equation is a quartic. We could expect as many as 4 answers. But what's cool about this problem, this shows you that there are only 2. So you can't always predict. The degree tells you the maximum number of answers. My greatest common factor is a 15x cubed. I pull that out, leaving me with a 3x minus 2. Notice I already had the 0, so all I had to do was factor. Now, I set each of the factors to 0. 15x cubed equals 0. Divide by 15. X cubed equals 0. When I take the cube root of both sides, because that's how I undo cubing something, I get the answer 0. Or another way to look at it at this level, what number raised to the third power would give you 0? Well, that would only possibly be 0 itself. And here, of course, I add 2 and divide by 3, giving me the answer 2/3. My last problem is an application problem. What this function measures, this function is sometimes referred to as a position function. T represents time in seconds after an object has been thrown upward. H of t represents the height. Okay, let's actually start with part B because that's the easier part. How high is the ball after 2 seconds? Well, all they're really asking you to do there is to find h of 2. Plug a 2 into the position function. Opposite of 16 times the quantity 2 squared plus 66 times 2. So our ball would be 68 feet high at the end of 2 seconds. Now part A, which is the harder one, is asking a little bit different question. Part A wants to know when the ball strikes the ground. Well, if you picture, let's say, a golf ball returning to the ground, when it's on the ground, its height would be 0. H of t would be 0. So anytime you're finding when an object is on the ground, you set its height to 0. So if you went to this function, h of t becomes 0. So 0 equals the opposite of 16t squared plus 66t. The first thing that I did, since a leading coefficient needs to be positive, whenever the number is in front of the x squared and you're solving an equation, it should really be positive. Makes things easier. So I multiplied both sides of the equation through by -1, which gave me this. And now I factor out a 2t. In parens, I have 8t minus 33. I set each of the factors equal to 0. This one, we get the answer t is 0. But that's not a significant answer. Of course we knew in the case of a golf ball that at time 0, it was on the ground. This is the significant answer. When I solve this, there's a little cutoff here, but you know what's there. 8t minus 33 equals 0. Add 33 to both sides and divide by 8. So when does the object strike the ground? 33 divided by 8 seconds later. So if you wrote that as a mixed number, that would be what? 4 1/8. So a little past 4 seconds, the golf ball returns to the ground. Okay. on to section 5.4.